Hi, my name is Lamont Johnson Taylor, and my final project for mechanical systems design is the elementary teaching scooter. There currently is a decline in the amount of students that want to pursue a career in engineering, and that's bad for business. Engineers solve a lot of our problems that involve critical thinking and problem solving as a whole, and just a few issues that are currently being solved by engineers and people of all types are cleaner energy sources, the problem of overpopulation, and even national security issues that arise on the day to day. My overall goal throughout this project has been to design a device that can be introduced to youth and help them spark that interest in engineering, and also introduce engineering as well as physics concepts to children at an early age so that they have some familiarity with it. There aren't that many constraints for a project like this, but the key things I want to include are the fact that I want the scooter to be able to hold a 200-pound rider. I want the scooter to be relatively cheap, as though I want this to be introduced in elementary schools and middle schools, as I don't see parents actually taking an interest in something like this. And I also want the target age group to be children ages 10 through 16. So this is the part that I was able to model in SolidWorks. As we can see here, this is a scooter with a deck, a handlebar part, as well as a scooter wheel fork. And towards the back of the deck, you can see that there's an opening for the rear wheel, as front wheels would go on the scooter fork. And the deck has a length of 21 inches, a width of 5 inches, and then a depth of 1.5 inch. Additionally, the handlebars have a diameter of 1.12 inches and a height of 22 inches and a width of 20 inches. I was not able to successfully model the fork, but I was able to obtain the fork from GrabCAD, and you'll see that in my references. But the fork has a clearance of 24 millimeters, which is perfectly fine. And then it also has a diameter at the top of the fork of 28 millimeters, which converts over to 1.12 inches. So all that should be seamless when it comes to the head comb holding the handlebars as well as the fork. So these are the wheels that are going to be used. These wheels are 100 millimeters wide. 100 millimeters wide. The inside diameter is 8 millimeters. And then these wheels have a hardness of 88A. And these wheels are also 24 millimeters wide, which again should be seamless with the fork. And then as far as the bearing, these bearings come with the wheels. And these are 608 sized ABEC 9 bearings. This here is the fork that I was able to obtain from GrabCAD. And the key features that I wanted to include with this fork, or to note with this fork, are the fact that the clearance at the bottom of it is 24 millimeters. So that should be sufficient when it comes to inserting the wheels. And then again, that top diameter is 28 millimeters, which allows for seamless integration when it comes to putting it all together. These are my key calculations. The only calculations that I felt would be sufficient for a project like this would be factor of safety calculations and making sure that I chose the appropriate material. So with the 3500 PSI, that is the yield strength of 661 aluminum, which most of the scooter is made up of. And then to the right, the axles are going to be made of carbon steel, and those are going to be 75,000 PSI. And the 1.9 PSI, that is the calculated PSI of the weight distribution on the deck of a 200-pound rider. And so as we can see here, it's good. It's good. A rider will not have to worry about their scooter collapsing on them. In conclusion, the scooter is able to ride smoothly with the weight of a 200-pound rider. The only thing that I'm not satisfied with is the cost, as it had a whopping cost of $1,000. And then these are all of my references for this PowerPoint presentation. Thank you for your time.